We are live, ma'am.
Thank you, sir. Sir, we can start now.
મમ્મીની ગાઢ આવી એના વાત ગાઢ આવી એનો
All participants are requested to be on mute throughout the session.
So, Lodi, should we start?
Yes, sir.
Okay. So, friends, welcome back. And in this session, we'll be trying to cover a non-parametric test. And it says, welcome you to be here. To teach us sure about virtue, values we hold on your command. Your love shines in each word. And that's a prayer to the God. And please always remember, I hear, I forget, I see, I remember, I do, I understand. So friends, unless and until you do the practice of it, you may not be able to understand. So what I am speaking is, it's likely that you may forget, you may not remember, but when you start doing it yourself with your hands, then you will understand. So never doubt your abilities for a moment in life. Wish you good luck and all the best, and hopefully you will have a wonderful time in learning about hypothesis testing. So we shall be talking about non-parametric test for hypothesis testing, but before that, if you have any questions, let me know. So before we move ahead into our journey, if you have any question, please don't hesitate, it's your program. If you have any doubt, this is the time when you can clear your doubt. Don't hesitate in asking questions. Anyone having any doubt, any question about whatever we have discussed in the previous session, please don't hesitate. So anyway, if you don't have a doubt, let's go ahead in our journey of testing hypothesis. And don't forget, every test requires parametric and non-parametric. And please recall about parametric test and non-parametric test, which we have discussed in earlier session. Is a test where we make assumptions about the population, and in case of non-parametric, we don't make any assumption about the population.
Some Miss Divya has a doubt. She's saying I get confused in identifying the type of data.
Okay. Divya, if we have labels like gender, male and female, okay, suppose you have a variable, let's call it rural background. And you have a rural, semi-urban, urban, metropolitan cities. These are nominal variables because they are just putting labels. You can put it 1, you can put it 2, doesn't matter. You can put it 2, you can put it 1, you can put it 1, 2, 3, 4, 3, 2, 4, or any order. Order is a material. We have just labels, nothing else. Such kind of a data is called nominal data. And where you have some ranking, then we have ordinal data. So for example, tuple, second tuple, third tuple, there is a hierarchy, young, middle-aged, old. There's a hierarchy. Income groups, less than 10,000, 10,000 to 20,000, 20,000 to 40,000. There is a hierarchy. So if you have hierarchy, then you have ordinal data. On nominal data and ordinal data, you cannot perform mathematical operations. You can't add them. Rank 1 plus rank 2 doesn't make a sense. You can't say it's equal to rank 3. 1 male, 2 female, you add, you subtract, you minus, you multiply, doesn't make a sense. So no mathematical operations can be done on nominal and ordinal data, except in ordinal data, we can do the ranking. That's it. Scale data is the data where you can perform all kind of mathematical, operations. Suppose wages. You can add wages of 10 people. You can add, you can subtract, you can multiply, you can divide. All mathematical operations are available in case of scale data. So where you can perform all kind of mathematical operations, that's scale. No operations nominal. No operations but ranking or some hierarchy, that's ordinal. So that's how we define now these 3 types of data. Okay, any other question if you have?
So there's another doubt. Please let me know the difference between variation test and central tendency test.
Yes, Dr. Gayatri. Dr. Gayatri, if I say my null hypothesis is mean of one is equal to mean of the other, that's a mean test. If I say my null hypothesis is variance of one is equal to the variance of the other, That's variance test. Here we use F, here we use T. Dr. Gayatri, is that clear? Saloni, any other query which you are getting?
Not as of now, sir.
Okay. Non-parametric test is applicable when your data is parametric, when it is measured on a scale level, and non-parametric when it is measured at nominal and ordinal scale, or assumptions of the parametric test are not satisfied. Nominal or ordinal and assumptions are not true. Okay. So let's see what tests are available in case of non-parametric test. Nominal data, one sample, two categories. If null hypothesis is proportion of male is equal to proportion of female by normal test. And if you are having more than two categories, then we have guys. So you have, say, rural, urban, metropolitan. I'm just taking three categories. So my null hypothesis is mean of rural is equal to mean of urban is equal to mean of metro. Same proportion, right? Proportion of rural, proportion of urban, proportion of metro. So here our variable is having more than two categories. There I can use chi-square test. And if you have two samples, nominal data, related samples, and if you have two classes, we use McNamara test. If you have more than two classes, we use chi-square, related, chi-square, unrelated, chi-square. So most of the cases you find you are using chi-square test in the nominal data. Related samples, two classes, quotient Q test. More than two, chi-square. Unrelated, chi-square. Shweta.
Please be on. Sir, I'll just do it.
Shweta.
Done, sir.
Then if you have the ordinal data, then we have one sample, goodness of fit, we use KS test. So KS test is non-parametric. Test of normality or any other distribution. And if it is central tendency, then we use what is called sign test. Two samples, related samples, we use Wilcoxon matched pair sign ring. If the two samples are related, we use a Mann-Whitney test. We have other tests, but these are the widely used tests, so I will concentrate on them. More than two samples, ordinal data, related samples, we use a Friedman test. And if we have unrelated samples, we use Cruxel-Wallis test. So friends, we have to only remember the name because we are not going to do calculations manually. The software will do the calculations for us, but we must know what test we have to apply under what circumstances. And please, I give you the parallel difference of mean test. If you cannot use parametric test, then use man-made test, which is non-parametric. Difference of means more than 2 samples and over. We use Cruxell-Wallace test of one-way ANOVA. If we have related samples or dependent samples, then pair t-test and parallel is Wilcoxon matched pair signed rank test. And if you have more than 2 samples, related samples, we use repeated measures of analysis of variance or RN. And if it is ordinal, we use Friedman test to analysis of variance by rank. So even if you don't remember the test, you have a list before you can remember it and you can check it. Okay. Any question before we proceed further? Any doubt, any query if you have? If you don't have a question, then I will start having questions from you. So it's a deal, either you ask me or I will ask you. Okay. I have a question. A researcher is doing research in behavioral finance. She has data of heuristic bias and gender. What will be the null hypothesis here? What do you think? What should he do in this case? What should be the null hypothesis? Some quick answer. Let me see who is that. Sanika. What does 1 sample and 2 sample mean? Okay. Sanika, 1 sample means marks of students of a school. I want to check whether the mean marks are equal to 70% or one sample. Because I'm taking sample of 1 school. Suppose if I take 2 schools, school X, school Y. Marks. What will be my hypothesis? Mean marks of school X is equal to mean marks of school Y. 2 samples. Both are independent. That what exactly it means. So, Sanika, Shala, is that okay? 1 sample, 2 sample? Okay. 3 schools. Gender. So, my null hypothesis is mean of 1 is equal to mean of 2 is equal to mean of 3. What tool I have to use here? What is the tool I have to use here? Because we have more than 2 samples. Okay, so coming back to this heuristic bias and gender. So no relationship between gender and biasness. Okay. Or the average bias of male is equal to average bias of female. Which should be my null hypothesis? Are we checking relationship? Are we checking difference? Or are we saying that bias is a function of gender? What is that we want to check? They were saying no relation between gender and bias. Anybody else? Gender and behavior is independent. So Manjari null hypothesis, they are no relation, they are independent. So this null hypothesis, no relation, that means they are independent. That means bias is not a function of gender. Will you like to check difference in the biases? Differences in biases? You might be wondering why I've taken this example, because many times researcher doesn't know what exactly he wants to prove. Does he or does she want to prove equality of the biases among gender, or association, or cause and effect between the gender and the biases? And if your hypothesis is wrong, your result will be wrong. So be clear in your mind what exactly you are looking for. Because the researcher is saying, my research question is to check whether there is a relation or no relation between the heuristic bias and the gender, but what it does, equality of the bias, mean of the male and equal to mean of the female bias. So equality is not the same thing as association. Please understand that. Gender and behavior is independent. That means a positive or negative relationship can be checked. Biasness is gender dependent or not. So Divya, I'm not saying what exactly you have to have. You have to decide, are you looking for this? Are you looking for this? Are you looking for this? No relation, chi-square. If it is measured on a scale, then independent t-test. Here you can make use of ANOVA or regression. So you have to be clear in your mind what exactly is your research question. And accordingly, you will pick up the test. Is that okay? Next. Consumer behavior and online buying in NCR region. Age categorized as young, middle age, old age. Total amount of purchase online in a month. What should be the hypothesis? Quick. Sanika, Divya, Gayatri. Shweta, Sonali, you can also try. Yes, many studies are possible. No relation between age and amount spent. Okay, the mean spending of young is equal to mean spending of the middle age is equal to mean spending of the old age. No difference in their spending. Okay. The spending which we have is a function of age. If you have positive, negative relationship between depends upon your alternative hypothesis. If your alternative hypothesis is a positive relation, then you're checking for positive relation. If alternative hypothesis negative relation, you're checking for negative. Mean if age is equal to the mean of spending, age is not associated with online purchase, relation between young, mid, and old, age and total amount spent online are independent in case of spending. So many responses I am getting from Divya, Manjari, Dheeraj, Ashmeet, Dheeraj again. I'm not saying what is good, what is bad. It depends upon your research questions. It depends upon what exactly you want to test. My simple submission here is you have to be very clear about the hypothesis which you're making. You want to check relation, don't make a hypothesis, means are equal. If you want to check relation, don't make a hypothesis that spending is a function of age, cause and effect relationship. So be clear in your mind what exactly the hypothesis you want to make and you want to. Okay. I'm not saying this hypothesis is more correct, this hypothesis is more correct. It depends upon your research objective, research problems, and your, hypothesis, research hypothesis about the data. Okay, so let me quickly do a unparametric test. Sylvia, are you able to find the annotator?
No,
What
sir.
we have seen here. Okay. Gender and anxiety level, if you see, if you want to see the data is like this. You can see the data in the variable view, data view. So you have a gender, you have the anxiety level. Okay, assuming the normality test cannot be applied. So my question is two sample, independent sample. Which test I should use? two samples, independent samples. Which test I should use? Analyze non-parametric tests. Two independent samples.
Ma'am, please be
Dr.
on
P.K.
mute.
Suresh Saloni, Dr. P.K. Suresh, just mute him. Gender is 1 and 2.
Thanks.
Manufacturing test. What does it say? It says p-value is if you see the p-value is 0.407, which is more than 5%. That means anxiety level between the male and female, that's same. No difference in their anxiety level. Okay, that's what you can conclude out of. I take another data set. Data set for file for nominal data. Um, we have the ice cream preference video and puzzle. So devote more time in video, male or female. I think I can show. 0 is male and 1 is female. Okay, so I go for two samples, male and female, man-Whitney test you can use. And suppose I want to know, is video game playing and the flavor of the chocolate they have are the same, are they different? So chocolate is independent, video is my dependent. So I have to use which test I have to use? I'm comparing means one way ANOVA, video games, favorite chocolate, It's different. We can have more statistics if you wish. We can have post hoc. So chocolate and the strawberry. Those who prefer chocolate and those who prefer strawberry, there is a distinct difference between them. You can see here. Strawberry and chocolate, there is a difference. Otherwise, there is no difference. So what does it mean now? Those who take strawberry they play more video games as compared to those who take chocolate flavor. Mean if age is equal to the mean spending in age of 3, 12. Divya, when you have more than 2 samples, then we have to use ANOVA. You cannot use T. T-test is used when you have 2 samples. So if you have 2 samples, use T-test. When you have more than 2 samples, we use yes, Smita, that's what we say. Mean and spanning in 3 age categories equal. So that means it is ANOVA. When you're more than 2, that means ANOVA. If you have only 2, say for example, I say analyze, compare means 2 independent samples, video games and male, female, 0 and 1. 0 male, 1. You see here, equality of variance assumption is not rejected. So we have to follow this. So there is a difference between the viewing of the video games, playing of the video games between male and female. Who uses more? Mean of male is more. So male is having more video gaming as compared to female. That will be our conclusion in this particular. I just close this file. So you have smokers and you have non-smokers. Okay. If you want to make a graph of box plot, you can go to chart builder. Box plot. It's then on x-axis we are taking y-axis we're taking light, and on x-axis we're taking smoker. And then the graph which we get. So you can see from the graph, smokers, non-smokers have higher life as compared to smokers, and the distribution is skewed distribution that you can check. And you can go for independent sample test. Or if I want to use a non-parametric test to sample, I have to use a Mann-Whitney test. So I go to parametric, non-parametric legacy dialog, two independent samples. Life is my test variable. The smoke is my defined group is 1 and 2. That's the result. So test says not much difference in their life, because my significant level is 0.12, which is more than 5%. So null is not rejected. So I can say that the smokers and non-smokers, there is no difference in their life. Okay. So like this, you can go on doing exercise with non-parametric tests. Then we see measures of association between two variables. If they are nominal, we use chi-square, but problem with the chi-square is highly dependent on the strength and the number. It does not give you any kind of comparative number. So instead of using chi-square, we use contingency. Kramer's contingency coefficient V, and the value of contingency coefficient is always between 1 and 0 and 1. And these are rules of thumb. So if you have a, coefficient of Kramer's V, and it's lying between 0.6 to 0.99, you see there is a very strong relationship between two dominant variables. So for example, here, let me open that ice cream case. Is there any relationship between the male and female and the flavor of the ice cream they like? So I go to null hypothesis, there's no relation between male and female and ice cream. I go to analyze, descriptive statistics, cross steps, flavor in the column. Statistics is phi or Kramer's V. No relation. the p-value is coming to be 0.225. That shows there is no relationship between the gender and the flavor of the ice cream they like. They are two independent. So null hypothesis, no association. Alternatively, there is association. So if you have nominal variables, then you can calculate Cramer's V or phi coefficient, whose value will always be lying between 0 and 0.225 doesn't show strong relationship. And if we have the ordinal data, then we can make use of what is called this IQ. The entertainment and the Cramer's V significant. That means there is association between the entertainment option and from this you will find that male prefers outdoor games, watching movie, while females prefer more, going to shop. Significant, that means there is a significant relationship between the gender and the choice of the entertainment option that you can easily find. If we have the ordinal data, then we use what is called Crooks-Cell gamma or Spearman rank correlation. Rank correlation and Crooks-Cell gamma, they are non-parametric. But on the other end, the Pearson which we use, this I can skip. If we take relation between scale level data, then we use a simple Pearson's which is parametric in nature. Okay, let me take some example and see this I can skip. Okay. Right. Do you see any association between the degree of a student and the major opted? Nominal. Nominal. In that case, we must use phi or Cramer's V. To get an answer. Okay, let me take another question, then I will show you how to do it. Okay, public response and the credit rating. Oversubscribe, fully subscribe, undersubscribe, and AAA, AA, A, triple B, double B, B. What is the nature of the data we have? Oversubscribe, fully subscribe, undersubscribe, ordinal data. Rating, ordinal data. And if you have ordinal data versus ordinal data, then either you can go for Spearman-Brun correlation, or you can use a Cruxel, Gottman-Cruxel gum. And I show you how to do it. You might be wondering what exactly I'm doing. Ordinal data set for we ask people to compare their bosses with with you and your bosses. So you have to give your opinion about yourself and your boss opinion about yourself. Okay, so you have you and your boss. Both are related. Both are ordinal data. I go to analyze, non-parametric, two independent, two related samples. Wilcoxon's, and the pair is you and your boss. That means your opinion and your boss opinion, they are almost same, no difference, because the p-value is coming to 0.194. That's how you can check. Strongly 114. Okay. Is there any association between the motivation level of a worker and review period of that particular work? So we have review period 1 month, 2 months, 3 months, 4 months, and so on. So background and the attitude. So I want to check whether there is association between the background and the attitude. Nominal. So I must go to analyze, descriptive, cross-step, background, attitude, statistics, rejected. That means the attitude of the people from rural background and the semi-urban background and the urban background and the attitude towards peer, that significantly associated. And from this table, you can make out who is having where most impact. So for example, urban, undecided. So most of the people of the urban, they are undecided about it. While most of the people here, semi-urban, very negative. So that's how you can interpret the results which you get here. Workers stay in the organization, low, moderate, high motivation level. I think I have this data. So you have motivation level and the let me take this problem. Who is spending more? Who is having more usage? The prepaid people or the postpaid people? And this is usage data, which is ordinal data. Prepaid, postpaid, two classes. So independent, analyze, non-parametric, legacy, two independent samples. Pre and post. Monthly usage is my test variable. Pre-post is my grouping variable. Non-Whitney test we are using. Define groups 1 and 2. So there is a distinct difference between the usage of the mobile between the prepaid and postpaid. Postpaid have higher use. If you see the mean rank 59.65. Prepaid is having lower use 42.06, and that's the value which we get here, significant. So Fred, that's the way you can do the analysis. But more of it you will get if you do yourself. My doing here will not help you in getting the feel of what exactly we are doing. So please do it yourself. Please give your preference for the following jobs. Job A, B, C, D. Preference ordinal data and jobs categorical data. So if you have categorical data, then cross step and use Cramer's B in that particular case. Postpaid, prepaid, we have done. You can also see who is using more, male or female. To sample, we have to use man-Whitney test, ordinal data. So friend, I hope whatever we have discussed today, it has made some sense to you. If you have any question, any doubt, please let me know. Don't hesitate. The last portion I have to rush through, but it doesn't take much discussion. You can do it yourself, but what you have to know is what is your null hypothesis and what tests you have to use. And I've given all the tests in different conditions. Okay. Any question here? Saloni, any question on the YouTube?
Sir, no, sir, no questions on YouTube.
Yes, sir. Sorry, I don't know why Divya is saying sorry.
So she was saying it earlier.
If data is collected using non-probability sampling method, can we go for testing of hypothesis? Yes, Mita, you can go. And in fact, in that case, you should use non-parametric because that does not make any assumption about, probability distribution, which you're using for sampling. Smita, is that clear? So when your data is not collected randomly, it's better if you use a non-parametric test. Smita, is that clear? Any other question? No? So thank you much. Thank you very much. This is all from my side. And hopefully you will have good learning. And
Thank you so much, sir. It gives me immense pleasure to deliver the vote of thanks for this session. I would like to express my heartfelt
before
thanks.
you do that, if
Hanji, sir.
any candidate or any participant throw you the question, you can send it to me later on. I will reply.
Yes, sir. Sir, I'll
Coming
do
to
that.
non-parametric test, Naveen, Kushal, just one. I think Smita, only non-parametric test. Yes, if your sample is non-random, it's better you go for non-parametric test because they do not assume any assumption about the sampling nature. Okay, so thanks everyone. Thanks Archana and Pradeep, uh, Sinha, Smita, Anu, Smita, all thanks to everyone. Okay, now please, Salon.
Yes, thank you so much, sir. It gives me immense pleasure to deliver the vote of thanks for this session. I would like to express my heartfelt thanks to Professor C.P. Gupta, sir, for sharing his knowledge about univariate and bivariate analysis with all of us. This session was very enriching, sir, and very, very interactive. All the participants are also thanking you from the bottom of their hearts, and it's always a pleasure to be learning any and everything from you. Thank you so much, sir.
Thank you, Salon. Thanks
Namaste.
everyone,
Thank
and
you.
all the best to all of you. And
Thank
should I leave?
Yes, sir. If any participant has any doubt, they can post it to me on Telegram. I'll forward it to sir. Thank you so much, sir. Thank you. Good night.